Sige. So, hello. Welcome ulit. Sige, we'll go. Medyo marami tayong cover today. Ito kasi yung start ng chemistry and marami talagang kailangan discuss sa part na to. Teka, yun na ba? Pin natin yan. Yan. So, ayun. So, we're going to... Okay na kayo? Are you guys ready na? Okay na kayo? Hello?
Opo.
Okay, sige.
Okay.
So, we're starting with Chem today. So, ito, sa first quarter na to ng grade 10 nyo. We're going to start with Thermochemistry. Ito ay actually for thermodynamics. So, bago tayo doon, ang thermodynamics ay simply yung study of changes of energy sa isang process. And ngayon, pero sa chemistry, ang forms of energy changes lang na meron ay in the form of work or heat, as I'll discuss later. Pero before that, let's start muna sa system, di ba? Ano ba yung system? Ang system ay yung pinag-aaralan natin mismo. So, example, meron tayong baso ng tubig na ang focus natin ay yung tubig mismo. Yung tubig yung system. Yung surroundings ay yung hindi natin pinag-aaralan or anything outside the system. So, in my example na glass of water, yung surroundings natin doon ay yung baso or kaya yung air around it. So, may tatlong klase ng system. First ay yung open system. May diagram naman tayo for this para mas mag-visualize natin mamaya. Ang open system ay isang system that can exchange both mass and energy with its surroundings. Ang closed system naman ay system that allows for transfer of energy but not mass or yung talagang matter itself. And yung isolated system, wala at all. Does not exchange mass or energy with its surroundings. So, ito yung example natin of of these three types of systems. Bale, ito yung open system natin kasi ayun, nagiinit tayo ng tubig. So, unang-una, there's energy in the form of heat na lumalabas and pumapasok sa system natin. Kasi nga, iniinit natin. Then next, dahil iniinit nga natin, lumalabas yung water in the form of water vapor. So, it exchanges both energy and matter. Letter B naman, a closed system allows exchange of energy but not matter. So, dito, ayan, nakatakip yung taas. So, ibig sabihin, walang tubig na lalabas dyan. Only heat will flow in and out of our vessel. And lastly, nilagyan natin yung vessel with double insulation, vacuum jacket. So, doon, wala talagang lalabas at all kasi kinocontain yung heat at tinatakpan yung taas ng pote. So, we'll go straight into it na. Kasi marami tayong di-discuss today. We'll start with this. Ang tawag dito ay mga thermodynamic quantities. So, ang una nating di-discuss ay yung change in yung internal energy or simply E. Ang internal energy ay yung total energy inside the system. So, tandaan nyo, kapag nagkaroon ng reaction, ng chemical reaction, sure tayo na kahit papano, yung internal energy sa loob ng system ay nagbago yun. Kasi nag-react nga eh. Kasi hindi naman magre-react ang isang reaction unless nag-change ang energy niya sa loob. Okay? So, when we calculate internal energy, so, di ba may chemical reaction tayo. Sabihin nating H2 plus O2 becomes water. So if you're going to calculate for the change in internal energy nun, magiging energy ng products, which is at the right side of your chemical equation, water, minus uh, energy nung internal energy ng reactants, which are your H2 and O2 nasa left side. So, ang tawag sa mga ganyang klaseng function that relies on yung products and reactants. Yung products, sila yung final state natin, di ba? Then yung reactants, sila yung initial state. Yung mga tawag sa mga quantities that rely only on the initial and final state are called state functions. So we'll learn more about that later. And ayun, so let's continue. So a change in the energy of the system must be accompanied by an equal and opposite change in the energy of the surroundings. This can be concluded because of yung law of conservation of energy, which we will continue to discuss later. So, just a few pointers. So, di ba kanina, ang ang equation natin ay E products minus E reactants for our delta E. Sabi ko nga kanina, parang ito yung final state niya, ito yung initial state niya. So, tandaan natin to, conceptual lang naman to, if delta E is negative, ibig sabihin, nag-release tayo ng energy into our surroundings, and kapag ang delta E natin ay positive, nag-absorb naman tayo ng energy from the surroundings. Okay pa? Gets pa naman? Gets?
Apa, yes.
Okay. Sige. Ito, in a diagram, ang tawag dito ay energy diagram. Baka pagawain din kayo nito. Ayan, so kita natin na it's always the initial and final state lang. So kapag negative yung pag negative yung delta E natin, dito siya bumaba yung energy natin. Pag positive yung delta E natin, ibig sabihin, dadagdagan siya ng energy, nag-absorb siya, so umakyat siya sa diagram natin. Okay? Sige. So, sabi ko nga kanina, there are only two types of energy transfer. So, first is yung heat, which is a result of difference in temperature between the system and the surroundings. And next is work, when object is moved by a force. So, we'll see later. Ano yon in terms of chemical reactions. So, ito yung sinasabi ko kanina na a change in the energy of the system is also accompanied by an equal change in the energy of the surroundings. Kasi nga, based from our first law of thermodynamics, nakita nyo rin to sa physics, conservation of energy. Energy cannot be created or destroyed. Basically, the total energy of the system and surroundings remain constant. So, ayan, equal to zero siya. Kasi nga, when energy in the system changes, an equal change is accompanied in the surroundings. So, dahil sa thermodynamics, yung energy natin between systems and surroundings occurs through heat and work. So, kumbaga, hindi na natin masyado tinitignan yung system and surroundings kasi alam naman natin andyan na lahat yan. So, we only focus on heat and work. So, our first law says, ito ay the direct consequence nun na ang delta E is equal to Q plus W. Ito yung isa sa mga important equations natin for today. So, ito may mga sign conventions tayo kasi you'll see later may example tayo. Tulad nga ng sabi ko kanina, pag negative, nag-release siya ng energy sa surroundings. Kapag naman positive, nag-absorb siya ng energy from the surroundings. So, if you look at our table, ito na yung importante, pag nag-absorb tayo ng heat, nadagdagan ng energy yung system, malamang. So, positive dapat yung sign nun. Importante yung signs dito sa chemistry kasi they say yung direction ng reaction mo, or what it describes how things flow in the chemical environment. Okay? So, next is yung work done. Pag work done on the system, we'll see an example later para mag-gets nyo. Positive yung sign natin. Kapag baliktad naman, if nag-release tayo ng heat, negative yung sign. And kapag work is done by the system, energy is released. I mean, negative yung sign nun. So all of this from the perspective of our system. Kasi, if you look at other books, baliktad yung sign convention yan. So, kaya nakalito siya. Pero ito, I think, I got this from the book na gagamitin nyo next year. And ganito rin yung pagkakaturo sa amin. So, let's just use this sign convention. Kasi may mga teacher na baliktad yung sign convention nila. Okay? So, ito yung example na sinasabi ko kanina. So, ito. Diba? Ito, pinakukulo ang tubig ito. Pinakukulo ang tubig. So, heat. Kaya naman nagkaka-energy transfer through heat para maging equal yung temperature, diba? So, ito pag nagpakulo tayo ng tubig, gusto niya maging malamig. Gusto niya maging same temperature of the surroundings. So, i-release niya yung heat niya sa hangin around it. Kaya, delta Q is less than 0. Ayan, bumaba yung kanya energy. Then, next is, kapag naman, example, meron tayo nito, ayan, tapos nilagyan natin na we start from ice tubig example. Siyempre, mas mainit yung water itself, 'di ba? So, kaya ang gagawin, a-absorb ni ice yung heat from the water para maging parehas na ng temperature. Yan. Kaya nagiging positive yung heat kasi nag-absorb siya. Gets? Okay Gets? Guys, gets naman?
Gets.
Okay, sige. Next. Ito, the easiest way to see work sa chemical reaction ay if yung reaction natin ay puro gas yung product. So, madali lang to. If nag-expand, ayan keyword, expand yung gas, syempre, ito yung mga gas particle, yung violet, yung purple. Syempre, as nagre-react, ano kasi to hydrochloric acid plus water siya. So, syempre, as nagre-react yung dalawa na yun, mag-form tayo ng gas. So, kapag nag-expand yung gases, kung isipin natin to in a piston setting, piston to So, pag nag-expand yung gas, syempre, di na siya kasya sa loob, mag-exert siya ng work towards that. Pero palabas ng palabas ng surroundings yun. So, therefore, it loses energy. Or, kaya yung sign convention natin for expanding gas is negative. Then, pagbaliktad naman, pag nagko-compress tayo ng gas, keyword compress, start from here, syempre, ibig sabihin work done on the gases na yon. So, nag-absorb siya ng energy. Right? Kaya nagiging positive yung work done. Okay? Here na. Gets, Gets? Okay. Sige. Let's go. Nakikita to? Sige. Based sa lahat ng sinabi ko sa inyo, sige, pakitry ito. Concept check natin ito for today. Take note, expanding gases. So yun, when gasoline burns in a car engine, let's just go straight. Excess heat is removed by the radiator. If expanding gases do 451 joules of work on the pistons, and the system releases 325 joules to the surroundings as heat, calculate delta E. Game, guys. Sige, try nyo. Simple lang yan. Okay? Sige. Try nyo. Ano guys? May sagot na? Guys. May sagot na ba?
Negative, 0.776 kilojoules.
Kinonvert mo. Sige, okay lang naman. Tama. Yan. Pero sabi ko sa problem in joules. Pero sige, it's fine. No problem. So, let's just do it simple. Delta E equals Q plus W. Ang Q natin, dahil ni-release natin as heat, negative 325 joules. Dahil nag-expand yung piston natin, nag-expand yung gases natin, so it does work on the surroundings, less than zero yung work, therefore negative. So delta E equals negative 325 minus 451, negative 776 joules. Gets naman? Okay? Guys, okay naman? Hello?
Apa.
Okay, sige. Yan, so that's the first part. Dito tayo magtatagal. Kasi ito yung pinaka main part ng thermochem, enthalpy and thermochemical equations. Ang tanong, by the way, hindi niya pa ito na-discuss sa school naman, di ba? Tama? Hindi pa.
Di pa po.
Okay, sige. So tama yung nakitang course outline. So before that, let's just try this. Let's just go through this concept kasi important siya to understand. So ayun, it's katulad ng kanina, di ba sabi ko pag nagre-react yung mga gases natin, pag nagre-react yung mga reaction natin, tendency nila ay to form gas. So, nag-expand yun, di ba? So, in a system that expands gas, di ba, sabi ko kanina, negative yung work. So, ang work sa isang flask na may piston, with a constant pressure P exerted on it, tas nag-change yung volume ay negative P delta V. Yan. Okay, so dinagyan natin ng formula yung work na tinutukoy ko kanina. So, sige, let's try this ulit. Teka lang ha. Let's try this ulit. Sige, go. Ano lang yan? Simple lang yan. Before we move on. Try ko nga. Okay. Okay. Mm-hmm. By the way, if you don't know the conversions, ayan, naka-given naman sila. Ano na yan? Plug in the formula lang.
$69 po ba?
Teka.
69 po ba?
Positive,
Wala.
negative. Look at
Negative po.
Yun. Tama. So, negative 69.4 joules. Bali, plug in the formula lang tayo. Nasaan yung ano ko? Yan, negative P delta V. Ang ano natin, ang pressure natin ay 988 over 760 atm. Medyo sinashortcut ko guys ha. Times volume change, 652 minus 125. Kasi may nakasulat sa whiteboard eh, sorry. Tas divide mo by 1,000 kasi liters. Then, you multiply this conversion factor, 101.3 joules. You'll get negative 69.4. Okay? Sige. Okay lang, di masyado importante. So, ito na yung main topic natin for today. Enthalpy, kasi ito, ang sabihin na nito, ito yung variable related to energy changes at constant pressure. Kasi most reactions happen in constant pressure naman. Hindi naman nagbabago most of the time. So, ayun, the enthalpy is defined as E, internal energy, plus PV, yung work natin. So, ito yung isa sa mga important formula natin for today. Delta H, which is equal to the heat under constant pressure equals delta E plus P delta V. Actually, kung titignan natin kanina, parang familiar yung terms. Kasi di ba kanina, delta E equals Q plus W. Itong Q, papalitan lang natin ng delta H kasi yun yung QP. Then ito yung negative P delta V. Di ba? So, if we rearrange terms, magiging delta H equals delta E plus P delta V. So, it's just a rebranding ng formula natin kanina. Then lastly, para natin tandaan sa chem, it's always H final minus H initial or H products minus H reactants. Ang change in enthalpy ay isang state function din kasi it depends on the final and initial states solely. So, ito yung ini-imply nitong dalawang ito lang yung ini-imply nitong delta H. Ito yung pinaka-importanting tandaan. Endothermic and exothermic reactions. I think you've heard these terms naman na before, di ba? Kapag delta H is greater than 0, heat is absorbed. Kung isipin natin, para siyang nasa reactant side ng reaction natin. We'll see an example later. And lastly, kapag exothermic, baliktad naman. Kung isipin natin, heat can be as a form of a product. Pag tignan natin yung chemical equation natin, so nasa right side siya. So ito yung example natin kanina. So if isusulat ko to ulit, magiging, di ba exothermic process siya? Sabi ko, pag exothermic process, product siya, so nag-release siya. So parang magiging ganito, CH4 plus 2O2 becomes CO2 plus 2H2O plus heat. Yan. So, yun yung ibig sabihin ko kanina. Then, ito namang isa, baliktad. H2O plus heat. Kasi inabsorb natin para maging liquid. Diba? Liquid water. Yan. Yun yung ibig sabihin nun. Then, tawag dito ay enthalpy diagram. Used to describe the state of your reaction. Okay? So, sige, concept check. Ito kaya, wag na yung draw an enthalpy diagram. That's fine. Determine if the reaction is endothermic or, exothermic. So, itong reaction na to, is it endothermic, exothermic, guys?
Exothermic po ba?
Yes, tama. Kasi, heat is a product. Okay? Next, ito.
Endothermic pa.
Tama. Kasi, heat is absorbed. Para siyang reactant. Diba? Yung sabi ko kanina. Sige. Endothermic siya. So, next. So, yung nakikita nyo kanina. Diba? Ayun na siya. Ang tawag dyan ay thermochemical equation. So, ang thermochemical equation ay balance equation. Balance siya. Pero pansin nyo na, ano siya? We use fractional coefficients. Explain ko mamaya kung bakit. Thermochemical equation is a balanced chemical equation that includes the enthalpy change of the reaction. So, ayan, equation with the delta H change in enthalpy. Naalala pa kung paano mag-balance, guys, from last year ng chemical equation? Naalala pa? Hello? Naalala pa, ha?
Opo.
Okay, naalala pa. Sige.
Okay pa naman.
So, kasi, di ba sabi ko kanina, di ba pag nagbabalance tayo ng chemical equation, yung ginagawa niya sa Chem 1, ayaw nating may fractional coefficient. Gusto natin parati whole number. Pero dito sa thermochemistry, tandaan natin na okay lang gumamit nun kasi gusto natin itong compound natin or yung fino-form natin or dinidecompose nating compound is always studied per 1 mole of substance. Actually, yung ibang teacher nyo siguro next year, ang units na ipapakita dito, kilojoules per mole. Per mole of Al2O3. Pero in our case, sige, kilojoules lang. So, yun lang. Kaya pag nagbabalance, tandaan nyo, in thermochemistry, parating yung compound na dinidecompose ay parating 1 mole. Parating 1 yung coefficient. So, ito yung mga nangyayari sa thermochemical equations. So, parang bang parang bang system of equations lang to sa math. So, ang sign of delta H depends on whether the reaction is exothermic or endothermic. Di ba? Yan yung sabi ko kanina. So, ayan, we have this equation. Kapag reverse natin yan, ang delta H niya magiging negative. Right? Kasi, para maging 2 elements, ay para ma-decompose into solid aluminum and oxygen gas, itong Al2O3 natin, kailangan niya mag-absorb ng heat. So, para ma-vaporize siya, di ba? May heat dito. Kapag reverse natin yan, nasa na yung heat? Nandito na sa kabila, di ba? So, para bumalik siya sa kanina, kailangan mag-release ng Al2O3 natin ng heat, di ba? Para maging back to its substituent components. So, kaya yung delta H natin naging negative din kasi nasa right side na yung heat. Okay? Then next, magnitude. The magnitude of delta H is proportional to the amount of substance. So, sabi ko kanina, diba, ang unit nito pwedeng kilojoules per mole kasi ang term natin, thermochemically equivalent. So, ang 1,676 kilojoules, thermochemically equivalent sa 1 mole of Al2O3. Ganito rin dito. 1,676 to 2 moles of aluminum. And lastly, 1,676 to 3/2 moles ng oxygen gas. Mali ako ng type. Oxygen gas. Okay. And lastly, tandaan nyo to, syempre, sabi nga natin, proportional, di ba? So, syempre, pag nag-multiply tayo or nag-divide tayo ng coefficients natin, kasi ito ginawa ko, multiply ko by 2, di ba? So, pati yung delta H ma-affect din by whatever factor you multiply it. Okay, tandaan nyo yan, ha? Gets? Okay naman, guys? Okay.
Gets.
Okay. Sige, pag naman tinanong ko kayo, sagot naman kayo agad. Sige, next. So, ito. Ito ay isang part. Naalala pa kung paano mag-stoichiometry? Naalala pa, guys? Okay, sige try natin to. Didiscuss ko rin mamaya. Wait lang Sige, ako na nga lang muna. Sige, I'll start with this. So, susulat ko na lang yung given sa whiteboard. Stop ko muna yung sharing para makita nyo ako. So, nakikita ko, guys. Nakikita ko, Ayan, try natin Al2O3. Nakikita naman, guys. Nababasa ba?
Okay naman.
Mabasa.
Sige, An is plus 3/2 O2 gas. ang delta H niya ay 1676 kilojoules. Diba? So, how many grams of aluminum, 26.98 grams per mole, yung molar mass niya, can form when 1,000 kilojoules of heat is transferred? So, simple lang to. Bale, 1,000, di ba? 1,000 kilojoules naman. 1,000 kilojoules, di ba? Ito, ang focus natin ay mass ng aluminum, di ba? So, let's look at this, tsaka ito. So, meron tayo 1,676 kilojoules per 2 moles ng aluminum. Gets? Di ba? Tapos, ayan, okay na tayo, na-convert natin to moles. Then, ang sabi, how many grams? So, let's just multiply the molar mass, di ba? Ay, divide pala. So, 1 mole AL ay, joke.
Hindi pa ba baliktad?
Baliktad. Siya pala. Sorry. Isa pa. Okay baliktad. Isa pa. 1,000 kilojoules of pool. 1,000 kilojoules. Tapos, 2 moles. Yan. Aluminum per 1,676 kilojoules. Times, sabi ko kanina, molar mass. So, 26.98 grams. Aluminum per 1 mole ng aluminum. So, try natin sa calcu. Ano lalabas? 1,000 times 2 times 26.98 divided by 1,676. So, we will get 32.19 or ng sig figs ba to? 4, di ba? So, mga 32.20 grams. Gets, guys? Gets kung paano mag stoichiometry sa sa ganitong klaseng setup? Gets naman, ha?
Apa.
Okay.
Gets.
Sige. Now, let's move on. Kayo naman, try natin. Teka, ha? Teka. Yan. Okay. So, yan, di ba? Sige, eto kaya. Naturo ba sige. Naturo ba sa inyo kung paano paano magsulat ng chemical equation? Yung parang ganyan ang binigay. So, ito actually, sige. Sige, gawin natin yung A. Gawin natin yung A together. Kaya, nakita yung problem, di ba? Nakita naman? Sige, sulat ko muna dito.
Apa.
Sige.
Kita na.
Sige. Marunong naman siguro kayo, no? Kapag nag-switch between ako ng pwede niyong ipin yung presentation or kaya yung sinusulat ko. Ay, alam niyo naman siguro yun, no? Tama ba? Sa Google Meet. Ganun siya. So, ayan So, pipin ko muna yung presentation. So, ayan. KBR. Sige, para lang may idea kayo. Kasi important to eh. Kapag nag-decompose siya, ito siya. It's solid potassium plus Br2. Yung pinaka-stable niyang form. Sige. I'll take this for you. So, sige. Balance ko to. Ito, 1/2. Kasi sabi ko, bawal sa thermochemistry, gusto natin na parating 1 mole ito. Okay, gets? Sige Ngayon, ito na yung balance equation. Kopyahin nyo na lang. Ngayon, try nyo letter B. Sige try. Take note, itong nakikinig itong equation natin, chemical equation siya kapag nag-decompose yung KBr. Ang tanong natin, ay magfo-form yung KBR. So, ingat sa sign. Okay? Sige, pakitry. I'll just get water. Sige, pakitry na lang ha. Okay, so kamusta naman?
Nakuha ko po mga negative 33,000. Mga ganun.
Okay, tama. Sige. Um, sige, let's try this naman. Sige nga. Explain mo nga sa amin, Mo, kung bakit negative 33,000.
So una, ko-convert natin yung 10 kilograms to 10,000 grams.
Okay.
Thus, we get how many moles of potassium bromide there are in 10,000 grams of that substance.
Okay.
So, we divide it by 119.
Okay.
Then, after that, that amount of moles, we multiply by 394 kilojoules to get how much energy is lost in the process.
Okay. Sige, tama. Ayun, lost in the process. Tama. Okay, good job. Sige ano lang, gets ba ng iba kung bakit negative yung sign? Gets Kasi, ang mangyayari ay babaliktarin ko to. Kasi ang sabi sa problem, nag-form yung KBR natin. So, yung delta H natin ay negative nung nasa given. So, then we just use the same process kanina sa stoichiometry. We would get negative 33,000 joules. Kilojoules pala. Okay? Sige let's go. So, ito na yung matagal. So, Hess's law used to find the enthalpy of any reaction. Kasi, ang reaction, hindi lang siya simple para, di ba, H2 plus O2, water agad. Tingin mo yun ang ginawa niya? Hindi, marami. Marami pang pinagdaanan yon para maging water yung simple nating hydrogen at oxygen. So, for information, Hess's law is used to find the enthalpy of any reaction. So, the enthalpy change of an overall process is the sum of the enthalpy changes of its individual parts or steps. Ayan, mathematical notation. Pero di nyo na kailangan tandaan yan. So, ito yung steps niya in words. Pero I'll show it to you step by step. So, ito. Let's go, Let's go. Sige. Paki-take note na lang yung mga equation. Okay, Kasi, hindi pala ako nag-share. Sorry. Isa pa. Ulitin ko lang, sandali. Sorry. Okay. Sabi ko kanina, ito na yung focus natin. Hess's law used to find the enthalpy of any reaction. The enthalpy change of an overall process is the sum of the enthalpy changes of its individual steps. So, sabi ko nga kanina, yung water, hindi lang H2 at O2 yan agad. Marami yung pinagdaanan para maging water yan. Okay? Sige Then the enthalpy change of an overall process is the sum of the enthalpy changes of its individual steps. So, in yung mathematical notation niya. Okay? Then ito yung process in words. Okay? Ito yung ano niya ng in words. Sige, try natin. Okay? So, I'll show you how to do it. Paki-take note yung mga equation, guys. Sulat ko muna sa board. Kasi, step by step natin to. Ayan, nababasa. Ay, sige. Okay Stop sharing. Then, ayan, nakikita na ba yung Nakikita ba yung nakasulat dito?
Apa.
Okay.
Kita po.
Sige let's do it step by step. So, ang unang yung gagawin, identify natin yung target equation. So, ano yung target equation natin? Itong overall reaction na to, di ba? Itong CO plus NO forms CO2 plus 1/2 N2. Ito yung hinahanapin natin ng delta H. So, ito. Kailangan, ang goal natin, kapag pinag-add natin itong dalawa, as in like a system of equations, ito yung lumabas. So, kailangan natin mag-multiply ng mga coefficient at mga kung ano para maging kapareho nito. So, ano lang to? Inspection muna. Inspection. So, tingin nyo, itong unang equation natin. Tingin nyo ba dapat i-reverse ko to or dapat may i-multiply ako to it? Tingin nyo.
Mukhang okay na.
Okay na. Kasi, yung CO nandito na sa left side, yung CO2 nandito na sa right side. So, okay na. Itong 1/2 O2 na lang. Kailangan natin itong matanggal. Sige. Okay. Next, itong pangalawa. Tingin nyo, ano dapat gawin ko?
I-flip po.
I-flip. Tapos,
Baliktad.
sige, flip ko Flip ko muna. Tapos, ano pa?
Multiply by 1/2 ba?
Multiply by 1/2. Kasi, yung coefficient ng NO, 1. Multiply ito by 1/2. So, cancel. 1/2 na to, 1/2. Okay. Yan, okay na, di ba? Pwede natin pag-add. Add natin. Okay. Sa chem, dito, kapag, di ba 1/2 O2, gusto natin matanggal. Ito rin, nandito siya. Pag nasa opposite side sila ng equation, ka-cancel yan.
Pwede i-cancel.
Cancel yan. Okay, tandaan yan So, okay na. CO gas plus 1/2 NO plus NO, gas, forms 1/2 N2 plus CO2. Yan na. Okay na. Ngayon, once na gawa na natin yan, tsaka natin gagamitin yung Hess's law. So, ano yung mga ginawa natin? Yung first, wala tayong ginawa. So, buburahin ko to ha. Yung first, wala tayong ginawa. So, negative, maliit kasi yung whiteboard ko, sorry. 283.0 kJ. Tapos ano ginawa natin sa second? Finlip natin, tapos multiply natin by 1/2. So, parang negative muna ng 180.6 times 1/2. Yan. So, once we add that, ang lalabas ay 283 plus 90.3. Yan, negative 373.3 kilojoules. Yan ang ano natin, yan ang delta H reaction natin. Okay?
Amazing.
Sige Ngayon, try nyo naman, kayo naman. Teka ha. Teka, excuse me. Sige nga. Game. Kayo naman. You see the given? Sige kayo naman. Teka. Ayan. Nag-gets naman yung tinuro ko kanina. It's just like para ka lang nagsosolve ng system of equation sa math. As at the same time, parang nagbabalance ka lang din ng chemical equation, di ba? Parang ganun lang. It's just a simple matter of checking na, dapat ito ganito rin makita ko doon. Ayun, okay? Para may practice kayo for this, check out nyo na lang yung i-release ko mamayang exercises for you. Kasi, there are times na pwede maging sobrang complicated dito. Also, para makita ko yung working nyo, nalimutan ko sabihin. Okay lang kahit scratch. Basta padala nyo yung, I'm not requiring a elegant solution. Gusto ko lang makita how you did it. Yung working nyo for this item, padala nyo sa GC once you're done. Okay? Para makita natin. Teka ha. Yung iba ba? Okay. Sorry. Ito. Kamusta naman? Okay naman? Sige. Nakita ko ng kay Mo. Sige yung iba. Para sure tayong gets nating lahat. Oh, guys. Kamusta na? Pag nahirapan kayo, don't, kayo mahiya. Can have more examples on this. Hanap na ako ngayon. Silberberg. Ay, mali. Martin. Okay. Don't worry naman pag dito sa Chem, kahit di masyadong yung solution, kahit di masyadong in-depth, it's okay. Let's see yung given natin. Megan, ito, check again. I'm sure may nalimutan kang gawin. One, two, three, four. Sino na lang kulang? Si... Si Eliza. Let's just wait for, para sure tayo. Sige. So, all good. Sige. So, sa mga lahat na nagbigay, okay naman. It's all correct. Good job. Yun, for Megan, ingat lang kasi, ayun, baka malimutan nyo na to do yung necessary na switching of signs or multiplying of coefficients sa dulo. Okay? Sige. Si Meliza, kamusta naman?
Nagsisend pa po.
Ay, sige, go lang. Sorry. Let's just wait. Hirap to ah. Okay. Sige. I won't go over each of your, we're not going to do the same thing na ginawa natin kahapon sa math. Pero all of you naman got the correct answer. Good job. Kay Megan lang, ingat lang next time. Kasi, ayun, baka manimutan na, kayo guys, ingat kayo in the future. Kasi, di ba, teka, pakita ko muna to. Stop presenting. So, okay. Sige, let's discuss this. Di ba, ayun yung equation natin? So, I'm sure napansin nyo naman lahat na itong CaCO3 dapat na sa kabila. Ito rin. So, we have to flip na. There's no other thing na kailangan gawin kasi if we check all the coefficients, okay naman na siya. Ngayon, so, pag inad natin yan, magiging ganito na siya. CaS plus 1/2 O2 plus CO2 form CaCO3S. Ingat lang sa kasi sa dulo pa tayo magre-resolve ng mga delta H natin, di ba? Ingat lang kasi baka malimutan nyo na ibalik ta rin or i-multiply by yung coefficient natin na multiply. Minus 178.3 equals negative 813.4 kilojoules. Okay? Sige. Sige, feeling ko you need one more example. Sige. Look at the screen na lang. Gawin natin to. Teka lang ha. Itong 6.68. Nakikita ba? Ayan, 6.68. Okay? Try niya. Sige, this time, answer only lang tayo. Nakita ko naman yung working nyo and get you naman. Okay, try lang natin para sure tayo. sige. So, ito na. Try natin, ha. Negative 2 times 38.6 minus 2 times ay, baliktad. 2 times 38.6. Okay. Sige, mga 2 more minutes. Wala akong black. Yun. Negative 103.4. Ayan, tama si Mo. Tama ka, Mo. Good job. Okay. Sige. Sige. Sige, let's try. I-discuss ko na. We have a lot more. Teka. Okay, so all of you are correct. Tama naman. Good job. Sige, discuss ko lang ng onti yung solution para lang sure tayo. Teka. Stop presenting. Ayan. So, ito yung equation natin overall. So, these are the given equations. Diba, pansin na agad na kailangan natin i-reverse pareho kasi yung mga elements nila nasa kabila. I mean, yung elements na nasa target or overall equation natin sa kabila. So, i-reverse natin pareho. Tapos, pansin natin na kulang ng coefficient. So, we multiply each thermochemical equation by 2. So, ayan. Yung huli, negative 2 times negative 38.6 plus sorry. plus 2 times negative 90.3 kasi binaliktad ko siya. Ayan, when we simplify it, ang lalabas ay negative 103.4 kilojoules. Okay, good job. Sige, kaya na yan. So, let's move on to the next part. So, ito naman. We're going to move on to the last part ng enthalpy kasi may calorimetry pa tayo. Ang standard enthalpy of formation. Ito ay Hacks method ng determining of delta H reaction. Pwede rin itong gamitin aside from the method na sinabi ko sa inyo kanina. So, enthalpy change for the formation equation when all the substances are in their standard states. May table of values to, so you don't have to memorize anything. Pag titignan nyo yung drive, actually, nandun na siya. Pero sige, send ko lang din sa inyo kasi we'll need this for the next part of our lesson. Teka, sandali lang ha. Appendix 2. There we go. Ayan. So, we'll use that in a little while. Ayan. So, yun ang table of values for that. Then, if bubuksan niyo yung table of values na yan, meron pa yung if makikita nyo, meron dyang standard entropy of formation and standard Gibbs free energy of formation. We'll discuss that in the next part of our lesson series. For now, let's focus on delta HF. So, standard state. Ano ibig sabihin ng standard state? The standard state is the most stable form of the substance at 1 atm and 25 degrees Celsius most of the time or 298 Kelvin. Ano yung mga example niyan? Makikita nyo naman, basta 0 yung delta HF na nasa table, if tinitignan yung table, standard state yan. Example, chlorine as a gas. Ang stable yan. Ang carbon as graphite, yung ginagamit sa pencil, and oxygen gas. So, ba't importante yun? Ba't ko sinabi sa inyo yun? Kasi for elements and compounds in their standard state, delta HF equals 0. So, ito, example for chlorine gas, 0 yung formation niya sa graphite, sa oxygen, sa silver, and for any other things na nasa table na yan. So, you'll also see. Yung bromine gas, ayan, example din yun. Okay? Sige. So, paano yun? If you look at this, so summation of enthalpy sa products minus summation of enthalpy of formation sa reactants is the overall delta H reaction. So, in short, pag merong ganito, diretso na agad. Okay? Let's look at this example. Sige. Bale, same principle lang ng kanina. Ha? Try natin ha. Sige, you have your table of values naman, di ba? Pakitry nga sagutan to. Gets ba? Gets? Sige, ano nga ba yung sige. Sige. Wait lang, sulat ko lang ha. All in H3. NH3, NH3. Meron ba dito? NH3 gas. Ayan, 46.3. NO 90.4. H2O. Si oxygen, ano yung delta HF niya? Yes, tama ako. Negative 904. O sige guys, ito yung mga tanong ko sa inyo. Ano yung delta HF ng NH3? Ammonium gas. Ay, ammonia gas. Para lang tingnan natin if you get it talaga. Negative. Wait, Eliza, ano yung, is this your answer ba?
Ay,
Yung sa,
Ammonia, okay. Sige, ako kasi iba nakita ko eh. Sige, pero, okay, let's go. Itong NO, ano yung nakita, ano yung HF niya? Based from the table na pinadala ko sa inyo.
$90.4 ba?
Yes, yun yung ano niya. Yung H2O. Gas, ano yung ano niya? Ano yung enthalpy of formation niya?
Ay, negative 241.8.
Yan. Okay, that's how you use the table. Wait lang ah. NH3 gas. Ako nakita ko sa NH3 gas ay negative 46.3. Ni Liza. Ayun. So, ingat lang. Okay, sige. Does anyone have answer?
Teka lang.
Sige.
Products.
So, di ba may coefficient yan? So, multiply each coefficient to the, HF.
Negative 904 po.
Yes, tama. Sige. We have a lot to cover pa. Sige, I'll discuss na lang muna. So, ganito siya. Tama. Sige. Ito. Let's look at this. So, ito yung equation natin. 4 moles of ammonia gas plus 5 O2 forms 4NO plus 6H2O. Ayan. So, simply, we look at the table. You look at the first column, di ba? Hanapin mo yung element and yung state niya. Tapos look at the column of HF. Gets naman kung paano hanapin yung mga HF siguro, no? Okay? Just look at the table. So, ang HF ng NH3 ay negative 46.3, ang NO 90.4, ang H2O negative 241.8. Sabi ko nga kanina, H products minus H reactants. So, paano yun? Ito. So, simply, dahil 6 yung tubig natin, 6 times negative 241.8 plus 4 times 90.4 kasi 4 times 90.4 minus reactants. Yung standard state to, tong si oxygen. So, dahil ganun siya, wala na siyang contribution agad kasi ang HF niyan ay 0, di ba? Tapos, itong negative 46.3 times 4 kasi 4 yung moles nitong NH3. Then, when we simplify everything, 904 kilojoules. Gets naman? Gets ba nung iba? Okay.
Yes po.
Okay. Sige. That's good. Ito. Ba't siya Hacks method? Wala lang to. A bit of knowledge lang. Kasi, teka, sandali lang Kasi, nakita nyo yan? Ganyan karami yung gagawin nyo kapag, diba? Kapag, ayan, nakita nyo tong simple equation na to? Ganitong karami yung gagawin nyo kapag kinuha nyo pa ginawa natin yung kanina, yung nagka-cancel pa tayo, ganun. So, shortcut siya, bale. Okay, yun lang. Let's not focus too much on that. Ayan pala. Hindi pa rin pakita sa inyo. So, kita nyo to, di ba? Ganyan lang kasimple equation. Mas ganitong karami yung gagawin natin. Katamad, di ba? So, Hacks method yan. Given na may table ka. Okay? Sige. Now, let's move on to another example. Ito, 900. Mali ako ng type, 904 dapat yan. Ito, sige, try natin. Ayan, let's try this out. I'll give you around 10 minutes to do so, ha? Ayan. Unang-una, para na ma-practice din kayo for Chemistry 1, syempre write the correct chemical equation. Then find the overall reaction, overall delta H. No need to look at the table kasi I gave all the values there na. Gets? Sige, try natin ha. Go, 10 minutes. Kasi meron pa tayong 2 topics left sa part na to. So, bit of a hint lang. So, dapat, ini babalance natin. Para hindi kayo masyado mahirapang mag-balance, guys, feel free to use fractional coefficients. Nine over 2, 5/2, 15 plus 9, 24. So, 6. Yun, huli ka. 5/2 times... over 2 times... Pwede kayo mag-cycle, guys, ha? Just say. P9. Minus 73. Okay, may nakita na akong mga sagot. Mo, ingat lang sa calcu. Tama si Neliza. Okay, that's good. Sige. We have 4 minutes left naman. Sige, let's discuss. Sige, so paano natin... Teka. Ito type na. Okay. Sige, let's discuss. Okay, so ito, let's stop presenting muna. So, paano natin ito babalance? Sabi ko sa inyo, walang masamang gumamit ng fractional coefficient. Kasi, parang hindi na kayo malitot, all. So, B5, di ba? B5. So, let's multiply 5 over 2 dito. Kasi B2, B5. Okay na. Next, H9. H2O. 9 over 2. Okay na. Tapos na tayo dito. Ito na lang, oxygen. Di ba? Meron na tayong 15 over 2 na oxygen. Meron na tayong 9 over 2 na oxygen. So, pag inad natin yun, 12. May 12 na oxygen dito. So, kailangan natin ng 6 oxygen. Tapos na tayo mag-balance. Di ba? Ang bilis. Ayan. So, wag kang mag-alala kahit fractional yung minumultiply mo dyan sa mga delta HF natin. So, let's see. Ayan na guys, ano lang yun, tip lang yun or pampabilis para hindi masyadong take note na pwedeng fractional coefficient yung pambalance natin. Kasi nakita ko yung iba sa inyo, yung pagbabalance nyo, meron pang 2 dito. Ganon. Ano yun? Pampabagal yun. So, ayan. 5 over 2 times yung HF ng B2O3, 9 over 2 times yung HF ng water minus 73.2 which is yung HF nitong B5H9 natin. So, ang sagot dyan ay negative 4543.1 or 0.05. So, good job sa mga nakatama. Good job, good job. Okay, so, we're in the last part of our lesson for today. Ang tawag dito ay calorimetry. Sige, so last calorimetry. So heat capacity, I think na-discuss yun naman to, ay yung quantity of heat required to change an object's temperature by 1 Kelvin. Well, actually, meron din kayo narinig na joules per degree Celsius, di ba? Wala namang masama doon. Basta, quantity of heat required to change an object's temperature by this unit. Okay, yun ang niya. Yun ang definition niya. So, ang formula niyan ay heat capacity is Q over delta T. Important yan. Then, meron ka rin naririnig na specific heat capacity. Ito, pinagkaiba lang nito, 1 gram of a substance or material's temperature by 1 Kelvin. So, ito yung formula niya. C equals Q over M delta T. So, dito na po, pag rearrange natin yan, yung Q or heat required ay equal sa, ang heat from that ay equal sa MCAT. Ito yung naririnig yung popular formula na MC delta T, mass times the specific heat capacity of the substance times the change in temperature. So, sige, concept check. Tingin nyo, dito, which of the following requires the most heat to raise its temperature by 10 degrees Celsius? Dali lang to.
Aluminum ba?
Bakit?
Kasi mataas yung specific heat niya.
Okay. Tama. Kasi ibig sabihin nun, pag mas mataas yung specific heat capacity, more heat is needed to change your temperature. Right? Whatever the unit is used. Sige. Ay, sorry. Molar heat capacity naman, same thing, pero 1 mole of a substance by 1 Kelvin. So, yun siya. Formula, Q over amount of substance in moles times delta T. Okay? Sige. Capital C pala to. Capital C yan. Just in case you're wondering. The specific heat capacity, small c. Okay? Sige, let's move on to our example. Sige, try nyo nga to. Okay. Ito yung first kong tanong sa inyo. Kailangan nyo ba talaga mag-convert from Celsius to Kelvin? Kapag gumagawa ng mga problems na to? Tingin nyo?
Hindi naman. Kasi yung difference,
Is the same thing, di ba?
di ba pag difference lang naman, since yung isang unit,
Yeah.
halos ganun din naman.
Oh, yun. Tama, di ba? Kasi kapag kinonvert mo, pareho pa rin yung difference nun. Yun ha, tip yun. Pag gumagawa ng mga problems on this, pampatagal yun. Analyze na lang in which situations you would need na i-convert pa yung Celsius to Kelvin or vice versa. Sige, go, pakitry. Tama ako. Sige. Baka kilojoules yan, Mo. Okay, sige, let's discuss. I'm sure, easy plug and play. So, bale, if you look at our screen, Q equals MC delta T. No need to convert anything. M is 125, C is 0.387, then delta T is 275. When you multiply those three, you'll get 13,300 joules or 13.3 kilojoules. Okay? Sige. Last. Ito, next. Uh, 2 minutes or 3. kilojoules. Grams per kg. Okay, sige. Um, ingat lang sa pagkaka... Ay, baliktad yan. Yan. Kilojoules per gram. Teka, ha? May sagot. To, ha? Wait lang. Try ko nga. 6.64. Sure. Joules per gram Kelvin. Sige, discuss na natin. Sige I see. Sige, let's discuss. 340 Q equals MC delta T C equals Q over M delta T. Ako, I will convert na agad 6,640 joules over 348 times 21.2. Tama kaya yan? Let's see. 640 Ayan, 0.9. Jeremy, ingat lang sa pag-convert. Pag di mo kinonvert, pag ano yan, pag using the units you told us, ano siya, 9 times, ito pala units ito, joules per gram Kelvin. Pag kilojoules per gram Kelvin, 9 times 10 to the negative 4th kilojoules per gram Kelvin. So, ingat lang, Jeremy. Okay? Gets naman, guys? Guys, gets ba? Ano?
Apa.
Okay.
Gets
Sige.
po.
Sige. Now, let's move to our next problem naman. Ayan. Sige, so, ito na yung last part ng lesson natin, calorimetry. I don't know if nagawa niyo na ito sa experiment, pero it is the process used to measure the heat of a chemical or physical change. So, calorimeter natin, ang tawag sa calorimeter na to ay yung coffee cup, which we'll discuss in a while. So, yung calorimeter ay yung device na ginagamit para sa calorimetry, malamang. Ayun. It measures the heat released or absorbed, bali. So, constant pressure, calorimetry. Used to measure yung heat absorbed or released for a chemical reaction undergoing in constant pressure, malamang. So, most of the time, use siya to find the heat of aqueous reactions, yung pag-dissolve, or kaya yung minsan, specific heat of capacity, ay specific heat capacity ng solids, kaya siya importante. So, ang tawag dito ay coffee cup calorimetry. Kinocoveran natin para walang escape na heat as much as possible, pero imposible yon. Thermometer to see ano yung initial and final temperature. Then, syempre, panghalo para mag-equilibrium yung system. Equilibrium, in this definition, means na pareho yung temperature ng system sa anyong surroundings. So, sa coffee cup calorimetry, tas last one, insulated pala to para walang lumabas na heat as much as possible. Sa coffee cup ay styro, which is a known insulator. So the heat lost by the system or the solid, ito, is equal to the heat gained by the water or liquid or solution or pati yung calorimeter mismo, which is the surroundings of your system. So, back to the basics pa rin, di ba? Systems and surroundings. Actually, dito, yung Q ng water plus Q solid equals 0. Kasi by conservation, dapat, and kasi closed system to or rather, isolated system. Bale, such as possible, dapat walang lumalabas na heat outside. So, by conservation of energy, Q systems or yung solid plus Q water equals 0. Surroundings natin. Okay? So, ayan, yun yung formula. Di ba kanina, MCAT, yun lang yung gagamitin natin. Alright? Then, take note, sa constant pressure calorimetry or coffee cup calorimetry, it ends kapag the equilibrium ng system or at the same final temperature na sila. Okay, sige. Ako muna. Paki-take note na ng given. Ako muna. Sige. Kahit dito, hindi pa rin kailangan mag-convert to Kelvin agad. Kasi, hindi naman kailangan. Kasi we are using the same units naman. Tsaka malito ka rin kapag kasi yung mga gantong problem, most of the time, mga solve function yung ginagamit para mabilis. So let's write the given muna. Teka lang surat ko na sa whiteboard. Water. M equals 50 grams. TI 25.1. 28 equals 28.49. Ayan, so let's look at the whiteboard. Nabasa nyo naman siguro yung problem, no? Okay, wait lang. Okay, so let's look at the whiteboard. We have, ito yung sa solid natin, ito yung sa water. Ano yung final temperature ng solid? Based from the problem. Tingin nyo, ano dapat?
Equal din sa final temp ng tubig.
Yes. Kasi by the concept, sabi ko, dapat pareho lang sila kasi equilibrium. Sige, let's go straight into it. Negative Q solid equals Q water. So, negative M solid times C solid, ito yung hinahanap natin, times delta T, which is 28.49 final minus initial, 100, equals mass water times seawater times 28.49 minus 25.10. By the way, ang specific heat ng water, teka, let me check. Nalimutan ko bigla. Pero dapat binibigay parati yun. Kaya lang specific heat of water. 4.186. Ang specific heat ng water, guys, remember is, basic to, 4.184 joules per gram Kelvin or kaya degrees Celsius, doesn't matter. Okay, yun lang. So, ayun, by doing this, so mahanap natin yung C solid. Okay lang ba? Idiretso ko na, guys, para di na kasya eh. So, ang C solid natin ay mass of water, 50 grams, times C water is 4.184, times the delta T, 28.49 minus 25.10. Tapos sa baba naman is yung mass ng solid, which is 22.05 times delta T, 28.49 minus 100. Yan. Ang lalabas dapat sa inyo ay, let's look at back the screen, is around Lalabas dapat ay, yan, 4.450 joules per gram Kelvin, or kaya 0.450 joules per gram degrees Celsius. The same lang yan, ha? Okay? Gets naman? Gets naman, guys? Gets naman? Gets naman?
Apa.
Okay, sige. Let's move on. Okay naman. Try natin to. Specific heat of water is ay, wait lang. Sige, go. Try nyo muna. Wait lang, ha. Oops, may kulang to. Sige, sandali lang, ha. Kulang. Specific. Teka lang, ha. Sige, go lang. Try nyo lang. Kasi may kulang yan, eh. May specific heat of, copper. Sulat ko, ha. Okay, sige. Ito. Ang type ko lang, ha. C copper equals 0.385 joules per gram Kelvin. C copper equals 4.124 joules per gram Kelvin. Ayan. Nakita ba yung problem, guys? Nakita naman siguro, no? Ayan. Try nyo. Gamit lang kayo ng solve function, guys. Para matry nyo rin. Kasi for this, mas magandang yun na lang yung gamitin natin. Anong density ng water? 1 gram per ml. Yun. So, tandaan nyo lang yun. So, basically, 1 ml of water is 1 gram. That's, hacks yun.
27.
20 grams. Let's see. Hindi ko masasagutan. Wait lang. Ito na pala. Ano sagot mo? 335.6. 336. Okay. Sige. Tama yan. So, good job. Teka, 5 minutes na lang tayo. So, di-discuss ko na kasi meron pa tayong last part for this.
See,
Teka lang.
this use more.
Teka lang.
I see.
Ayan ako to. Ayan. So, ayan. Given natin, 248 grams of copper. Then, we don't know the initial temperature of copper, and the final temperature is 39.9 degrees Celsius. For the water, 390 ml. That is essentially 390 grams of water. Then, Ti equals 26.6. Ay, 22.6. Then, TF equals 39.9. So, ito lang. Negative Q solid equals negative Q water. Negative M solid, C solid, delta T, which is, X, ay, 39.9 minus X equals M water, C water, delta T. So use your calculator for the solve function. You will get X equals 335.6 degrees Celsius. Ayan, take note, pag ganyan, don't convert na to Kelvin kasi magkakamali si solve function for that. Ingat lang ha. Then, ayan, correct. Good job, guys. Then, ito na, last part of our lesson today is, kung meron constant pressure, meron din constant volume calorimetry. Diba, naalala nyo kanina, paano gumamit ng work? It's P delta V. In constant volume calorimetry, the volume doesn't change. So, yung work natin is automatically zero. Kasi P delta V, 0. Q. Delta E equals Q. Okay? Hindi, take note, pinimeasure nito ay change in internal energy, hindi delta H. Yung pa pala isa. Okay? Ay, di pala ako nagpakita ng screen. Teka. Here's what I was saying. Ayan, balik tayo. Kung merong constant pressure calorimetry, meron din constant volume calorimetry. So, ayan, delta E, ang measure niya, hindi delta H. Take note. P delta V is 0 kasi doesn't change yung volume niya. Kasi ang work ay P delta V, di ba? Eh, constant volume tayo. So, walang work. So, therefore, delta E equals Q in a constant volume calorimeter. Ang other name niyan ay bomb calorimeter. So, ito, sige, I'll take point of this. Kasi ito, this is, hindi naman ito masyadong importante for you guys. Ito, tingnan nyo na lang muna yung given. I'll write the given on the board first. Kasi dito, marami tayong magagamit na formula. Okay, sige. Wait lang ha. Dali lang. Saan ba yung ginawa ko kanina? Okay, so let's start. Kailangan. Yan, so this is our given. So, ang tanong sa atin is, what is the heat capacity of the bomb calorimeter? So, let's start muna sa per mole of graphite. So, yung molar mass ng graphite. Teka ha, I'll just search. Namutan kong lagay dito. Parang guys ha. Last na to for today. Wait. Sige. Teka ha. Tagal. Okay. Alam ko na. Teka, sandali lang ha. Almost there. Ayun. Sige. Ito na. Game. Sorry. Okay, so first of all, let's determine how much heat was actually released. Diba? By stoic, diba? 0.8650 grams of graphite. Ang graphite pala is, nalimutan ko, is carbon, as in carbon, solid. So, ang molar mass niya ay 12. Then, we multiply kasi 393.5 kilojoules of per mole is released. Diba? Ang nalabas dyan ay 28.4. Tapos, diba, ang meron tayo kanina, formula for heat capacity is Q equals C delta T. Tama? Capital? Basta, something like that. Basta specific heat capacity times delta T. Yung isa sa mga formula natin kanina. Ito yung heat na na-release sa calorimeter. So, i-absorb ng calorimeter natin. So, 28.4 kilojoules over delta T, 2.613 Kelvin. Equals to, ang lalabas dyan ay 28.4 divided by 2.613 is 10.9 kilojoules per Kelvin. Yun na yung ating heat capacity. Okay? Gets naman, guys? Gets naman? Okay.
Gets.
Okay, sige. So, yun. That's our last for today. Ito, try nyo na lang on your own. Upload ko naman to. Challenge. This is quite of a challenge. Okay? Sige. That's all for today. Maraming salamat sa pagpunta ulit. Ayun, so naka 1 week na tayo and thank you so much. Sa Monday naman, ang natin is physics ulit. We'll have oscillations and we'll go with oscillations and waves sa Monday sa physics. So, ayun, today naka 3/4 na tayo ng first quarter sa chem. Ang next naman natin i-discuss sa chem ay yung second and third law of thermodynamics. Okay, yun lang. Sige, maraming salamat.
Sige, thank you po.
Sige, sige.
Thank you.
Bye.
Thank you po.